Miss Indria. Miss Indria is a bachelor landscape architecture with a strong interest in landscape ecology, environmental services, landscape management, and sustainability. And she has been actively involved in various projects and research focusing on nature-based solutions and ecosystem approaches. Currently, she serves as Environment, Agriculture, and Forestry Resilience Research Officer at RDI. And now, let's welcome our moderator, Miss Indria. The time is yours.
Okay, thank you, Fahmi, and good afternoon, everyone. And thank you for joining us today for the third series of webinar, Harmonizing Wetland Management, Sustaining Ecological and Livelihood Management for a Resilient Future of Southeast Asia. And our focus today will be on carbon capture in crisis, how government, technology, and communities can save wetlands. This webinar series aims to bring together experts and stakeholders to share knowledge and explore collaborative solutions on wetland management. And I'm excited to introduce our esteemed speakers for today's session. Our first speakers will be Kisha Muanya from the Wetland International Philippines, and she will present on policy and preservation for wetland management. Kisha serving as policy and advocacy consultant at the Wetland International Philippines, and she's experienced in environmental advocacy, specializing in disaster resilience, sustainable development, and mangrove conservation. She has led initiatives for Wetlands International and Oceana Philippines, focusing on policy advocacy, community engagement, and strategic planning for nature-based solutions and ecosystem protection. She is also a notable researcher and youth advocate. And our second speaker is Mr. Dede Sulaiman from WRI Indonesia, and he will present on technology and community involvement for sustainable wetland management. Mr. Dede is an experienced researcher specializing in peatland restoration and sustainable land management. As the research lead for peatland at WRI Indonesia, he assessed the impacts of peatland restoration and degradation, and his notable achievements include consulting for the UNCDD on Indonesia's land degradation neutrality report and serving as a soil expert for various organizations. And our last speaker is Dr. Suyadi from the National Research and Innovation Agency of Indonesia, or BRIN. He is a principal scientist at the Research Center of Ecology and Ethnobiology at BRIN, with expertise in forest ecology, mangrove restoration, and biodiversity conservation. With a passion for integrating science into policymaking, Dr. Soyadi has published extensively and patent innovations in ecosystem management and led significant restoration projects. Next, after their presentation, we will hear from our discussant, Ms. Emily Legiones, from the Global Water Partnership Southeast Asia and the Society for the Conservation of Philippine Wetland. She will share her insight on the topics presented by the speakers and also will expand on points made by the speakers. Mrs. Emmy is an environmental expert with over 20 years of leadership in wetland conservation and sustainable development. Currently, she serves as Executive Director of the Society for the Conservation of Philippine Wetlands and a member of the Steering Committee for the Global Water Partnership Southeast Asia. And she advocates for sustainable water management, and her work spans regional biodiversity efforts and advocacy for sustainable water management. And I encourage everyone to stay engaged, and we will have a Q&A session after the presentation where you can ask your question. Okay, next, before we move to the next session, we would like to take a group photo with all our speakers, discussant, and participants. And please turn on your camera and we will capture this moment together. I will give you a few seconds to prepare. Please open your camera. And you can use the virtual background that provided in materials folder. You can download it. Okay, I will give you a second to prepare. Okay, we will start the photo group. Smile, 1, 2, 3. Hold on. The next slide, 1, 2, 3. And for the last slide, 1, 2, 3. Okay, thank you everyone. You can turn off your camera. Okay, now we will start with our first session. Please welcome Kisha Muaya from the Wetland International Philippines, who will talk about preservation and policy, the future wetlands as carbon sinks. Please, Kisha, the time is yours.
Hello, good afternoon, everyone. I am Kisha Monya, the Policy and Advocacy Officer of Wetlands, and thank you for the invitation. I'm excited to talk about the future of wetlands as carbon sinks. Next slide, please. Here's my presentation flow. I will introduce our organization briefly and then understand, maybe most of us here are already familiar with wetlands, so maybe we can just a little bit review about wetlands. And we will be zooming out on the global carbon storage potential in coastal ecosystems and zoom in on the wetlands in Southeast Asia. And we will also discuss the emerging conditions in Southeast Asia wetlands, regional and international cooperation for transboundary wetland management, and of course, collaboration in driving wetland policy change. And the presentation will end by a call to action. Next slide, please. So, Wetlands International is a nonprofit organization dedicated to the restoration, conservation, and wise use of wetlands, and bringing back wetlands into a healthier and functional condition on a large scale is our vision. Over 2020 to 2030, Wetlands International aims to safeguard and restore tens of millions of hectares of wetlands, bringing multiple returns for nature and people. And our theory of change encapsulates the three main phases of our work, which is to inspire, mobilize, and upscale. These are the key ingredients of our organizational strategy for the period of 2020 to 2030. Next slide, please. We have 19 country offices across different regions. This is where we work and on coast and deltas. And next slide, please. This is where we work on rivers and lakes. Next slide, please. This is where we work on peatlands. Next slide. So let's go back to defining what wetlands are. According to the Ramsar definition, these are areas where water covers the soil, either permanently or seasonally, includes both freshwater and coastal and marine ecosystems, and characterized by waterlogged soils and adapted plants and animal communities. And it account for around 6% of Earth's land surface globally. The Ramsar definition is intentionally broad to ensure that conservation efforts encompasses diverse ecosystems that provide critical services, including water purification, flood control, carbon storage, and biodiversity support. And throughout the presentation, I will focus on coastal wetlands. Next slide, please. So, since we know most of the values of wetlands, let's talk about coastal wetlands and its potential as carbon sink. And we all know that the values of both coastal and inland wetland ecosystems to society and the economy are the highest of any type of ecosystem. And we can find wetlands wherever land and water meet. They exist in every country across the world and every type of region, maybe be it polar, tropical, wet, dry, high and low altitude. And it takes in various forms and are highly dynamic, connecting mountains to the sea. Next slide, please. So in the next slides, we will be focusing on the value of wetlands as carbon sink, as I mentioned earlier. As you can see here, This is the global carbon storage potential from the World Ocean Review 2024. This is for coastal wetlands, so tidal marshes, mangroves, seagrasses, and experts often refer to the carbon sequestered by seagrass meadows, tidal marshes, and mangroves, and even kelp forest as blue carbon. This map shows for all coastal countries the average annual carbon sequestration potential for the three ecosystems. And this map shows the average annual with the three ecosystems combined being an indicator that the ecosystems are healthy. From this map, we can see the high carbon storage potential of Southeast Asia from 1 to 11 million tons of carbon annually. And this only signifies the role of wetlands in the region and the urgent need to ensure protection and conservation. Next slide, please. For Southeast Asia, we have a high below ground carbon stock for mangroves and seagrasses, but with the evolving threats on the ground, land conversion, with this disruptive and destructive activities, this will change and will continuously do so if we don't establish targeted, socialized, and even regional scale safeguards for the restoration and protection of these ecosystems. Next slide, please. In the slide, we can see two different scenarios, A being the baseline scenario and B as high range emission scenario. According to the study of Kirili Rogers et al. From the Cambridge University Press, in the short to medium term, climate change may increase the capacity of blue carbon ecosystems to capture and store atmospheric CO2, largely due to the processes that respond to elevated carbon dioxide and temperature and influence carbon capture and storage. So the threat to in situ coastal wetlands makes local land use and coastal protection the key determinant of long-term survival, driven by retreat of the blue carbon ecosystems to higher elevations. And investment in coastal wetland conservation and restoration provides benefits not only for the preservation of ecosystem services, such as coastal fisheries, but also a promising opportunity for nature-based mitigation and adaptation. And critical knowledge gaps needs to be overcome before the full benefit of blue carbon can be realized, especially for Southeast Asia. And with climate change, our coastal landscape will change. With sea level rise, these are the factors and the impacts of climate change that we cannot control. And seagrasses and mangroves need to adapt and slowly move landward, but that would be hard in some cases without human nature-based interventions and support. Next slide, please. So let's take a closer look at how these coastal ecosystems store underground carbon. So the amount of carbon that coastal ecosystems store underground in the long term depends on a number of factors. So this include inputs, materials from terrestrial sources or from other marine regions, as well as the amount of biomass consumed by animals or decomposed by our microorganisms. And despite the importance of ecosystem services they provide, vegetation-rich coastal ecosystems are declining in areas worldwide, not just in our region. And this is alarming. Up to 50% of all tidal marshes and about 1/3 of all seagrass meadows and about 35 to 50% of mangrove forests have been lost over the past 100 years as a result of climate change, coastal development and construction, agriculture and aquaculture, marine degradation, overfishing, and other intensive uses. And with carbon credits on the rise, we have to be mindful. We have to ensure that the investments that will come will be used to ensure that high quality blue carbon are prioritized and protected, and the benefits will be shared fairly across the stakeholders, especially the local communities. And we have to be vigilant because maybe others will take advantage of blue carbon, and because this is a controversial concern, that's why we need to have a clear blue carbon and carbon credit framework policies in Southeast Asia and within our countries. Next slide, please. So wetlands in Southeast Asia, there are almost 2 million square kilometers of wetlands in Southeast Asia region. At present, there are 61 and maybe there are some additional from the other countries as well. Wetlands of international importance, or Ramsar sites, occupying a total of 26,592 square kilometers in 8 ASEAN member states. And approximately 25 million hectares of peatlands are also found in Southeast Asia, and of which 70% are in Indonesia. And they're our best ally in the fight against climate change, as we talked about earlier, but they're also considered as the planet's greatest natural carbon stores. But despite all of that, despite all the benefits that we can get from wetlands, they are now the most threatened ecosystem on the planet because human activities contribute largely to the rapid loss of the world's wetlands. Next slide, please. So Southeast Asia has a huge role to play, and as a region with cascading and compounding risk, and with the worsening impacts of climate change, focusing on wetland-based solutions is an urgent action moving forward. The map on the left side is the protected areas map based on live WDPA data consolidated by the ASEAN Center for Biodiversity. And in this map, we can see the protected areas in Southeast Asia. But seeing this makes me reflect on my exposure on the ground during our fieldworks. And not all of these protected areas have the same management structure. Not all are in a healthy condition. And most of these protected areas has their own localized and evolving threats and challenges. And the map on the right shows the Ramsar sites, wetlands of international importance in Southeast Asia as of 2022. At present, there are a few additions. For example, just this month, we have 2 additional Ramsar sites in the Philippines. Next slide, please. This is just a closer look of the protected areas in Southeast Asia. Maybe I need to zoom more because I think I missed a few. But let's note that not all of these are wetlands, and not all wetlands are established as protected areas. And an efficient management system and robust enforcement of policies are essential for the sustainability of protected areas and Ramsar sites in Southeast Asia. These wetlands face evolving threats such as urbanization, pollution, illegal resource extraction, and other threats we will be discussing in the next slides. And effective management ensures the maintenance of ecosystem services, which is critical for biodiversity, livelihoods, and climate resilience. It also prevents overexploitation and degradation through proper zoning, monitoring, and the involvement of local communities. So we really need strengthened enforcement of policies, especially updating those policies, paired with collaborative efforts among governments, private sector, and the NGOs can help address cross-border challenges and align actions with international frameworks like the Ramsar Convention. And prioritizing these steps is vital to safeguarding Southeast Asia's wetlands against current and emerging threats. Next slide, please. We will be now going on to the next part. Can wetlands still be a carbon sink? Next slide, please. Before we proceed, let's go back to why wetlands are crucial as carbon sinks. In this slide, we can see the land and ocean temperature departure from the average of, as of October 2024, this map is from NOAA. And climate change significantly affects wetland ecosystem, altering their ability to provide essential services. And rising temperatures, sea level rise, and extreme weather events disrupt wetland hydrology and leading to habitat loss, salinization, and decreased biodiversity. Wetlands themselves, like peatlands and mangroves, store vast amounts of carbon, and their degradation releases greenhouse gases, accelerating climate change. However, wetland-based solutions can play a vital role in combating these impacts. And in the next slide, next slide, please. In the World Risk Index 2024, we can see here that in terms of exposure, in terms of vulnerability, top countries at risk are from the Asia region. At number 1 is the Philippines. This only signifies the urgency for us to take action. Next slide, please. So to answer that question, if can wetlands still be a carbon sink? Yes, of course. Wetlands in Southeast Asia remains a critical ecosystem for carbon storage, but their ability to function as effective carbon sinks is increasingly under threat due to human activities and climate change. So these are the challenges, the threats. Despite their potential, we face significant degradation due to land conversion or reclamation, urban expansion, climate change, pollution, and unsustainable use. Next slide, please. Next slide, please. So here are some examples of regional and international cooperation for transboundary wetland management. In the Mekong River, this across 6 countries like China, Myanmar, Laos, Thailand, Cambodia, and Vietnam. We also have Sulawesi Marine Ecoregion and the Coral Triangle Initiative. Next slide, please. So, yes, we have challenges, but there are also opportunities that we can work on. And note that these are not in order and only recommendations for consideration. Like, we need to strengthen scientific collaboration for data generation and data sharing across the region. We need to update and align our wetland policies at the regional landscape and leverage international climate funds, develop transboundary wetland management plans, like invest in green infrastructure and pollution control, developing regional financing mechanisms, and of course, this is very important, knowledge sharing, effective knowledge sharing. Next slide, please. And we are not starting from scratch. There are existing initiatives in ASEAN that we can build on and we can work on together. So we have the ASEAN Peatland Management Strategy, we have the Coral Triangle Initiative, the Asian Wetland Symposium, but these are not all of it. There are other initiatives as well, regional and local. Next slide, please. We also have international and regional cooperation frameworks like the Ramsar Regional Center East Asia and the Conference of Contracting Parties, and there are transboundary Ramsar sites. Next slide, please. There are also international governance discussions where we can lobby for the inclusion and prioritization of wetland-based solutions, such as the Convention on Biological Diversity, the UNFCCC COP, and the Asia-Pacific Ministerial Conference on Disaster Risk Reduction. Next slide, please. But all of this, a holistic approach for wetland conservation in Southeast Asia and prioritizing the protection of these vital carbon sinks necessitates a coordinated effort, not just regional, but local, national, and regional policy interventions, ensuring that local needs and realities inform national strategies, which are then integrated into regional cooperation framework. So for the Philippines, we have pending bills, we have past bills and ongoing consultations for improvement of existing frameworks. And of course, we want to lobby for the inclusion or the integration of wetlands into our NDC or the nationally determined contributions. Next slide, please. So collaboration amongst institutions and driving wetland policy change is very, very important. And we need to address as a region, as different stakeholders, the coordination gaps, the funding limitations, the policy gaps. And these are just a few of the recommendations to enhance collaboration. We need to establish multi-stakeholder platforms, need to invest in capacity building among the institutions, especially the direct stakeholders managing the wetlands in our region and our areas, the local areas, leverage global frameworks, and maybe we can explore having a regional blue carbon action partnership for Southeast Asia. Next slide, please. So our call to action is clear. For decades or even centuries, these wetlands have been crucial carbon sinks, and recognizing the critical role of wetlands in sequestering carbon as is very important. It's clear for us the future of wetlands can be a carbon sink or a carbon source, because we need to, right now, as I mentioned earlier, we have cascading and compounding risk on wetlands, and we need to take action, improve our policies before these vital ecosystems, in terms of degradation, transforms them into significant carbon sources, which will be contributing to climate change more. We have a choice to make. So this is not just for government. This is for policymakers, institutions, the private sector, and communities. We need to prioritize and implement science-based policies to strengthen wetlands conservation and ensuring their role as carbon sinks and enhancing ecological resilience as well across Southeast Asia. Together, let's champion wetland-based solutions, because if not now, if we cannot restore it now, maybe it will be a carbon source in the future. And if these carbon sinks will not be restored, the damages will be irreversible. So the call for us is to really improve what we have. Let's not start from scratch, but let's improve, let's address the gaps, and let's connect the dots across the region. Next slide, please. For collaboration opportunities, please contact us through email or visit our website for more information about our work. Thank you so much.
Okay, thank you very much, Keisha, for sharing this valuable insight for the wetland management through policy action. And next, I'd like to invite Mr. Dede Sulaiman from WRI Indonesia to speak about technology and community involvement for sustainable wetland management. Please, Mr. Dede, the time is yours.
Yeah, thank you so much, Bu Indria. Hope everyone can hear my voice clearly. But before I start my presentation, could you help to allow me to present my presentations? I mean, I will share my screen by myself.
Okay, wait, we will let you present by yourself.
Can you see my screen now?
Yeah, we can see it.
Okay. Okay, thank you so much, Ibu Indria, and good afternoon, everyone. Thank you for joining today's webinar. I'm really excited to be involved in this webinar. And in these sessions, we will be discussing about the exciting topic on technology and community involvement for sustainable wetland management. We will be covering these three topics. The first one will be about technology for wetland inventory and mapping. And then we will talk about the real-time wetland monitoring. And the last one, we will discuss about the community involvement in wetland mapping and inventory. When the Kamati Bu Indria contacted us to bring this topic in this webinar, we were really excited because it really aligns with our activities, especially in peatland related activities. So I'm going to start with the definitions. Actually, it is already explained by the previous speaker, Keisha. Refer to Ramsar Convention, a wetland is an area where the main element influencing the ecosystem is water, or we can also say that this ecosystem is covered by the water. So following these definitions, there will be a lot of type of wetlands that can be divided into five main category. The first one is the marine or coastal wetlands, and estuarine, a place where the fresh and saltwater mix. And then lacustrine, wetland associated with lakes, and riverine, wetlands along rivers and streams. And the last one is palustrine, also known as vegetated wetlands, that also include peatlands in this category. There is also one additional wetland types, which is human-made wetlands. Talking about the importance of wetlands, this ecosystem is really important for us because it gives a lot of benefits for us. This ecosystem is important for biodiversity hotspot because because wetland provide habitat for a lot of animal and plant species. And as mentioned by Kisha, wetland also really important in climate regulations because it acts as a carbon sink and also carbon storage. In particular for peatlands, this ecosystem holds around 1/3 of global soil carbon. So it will be really important for climate regulations. This ecosystem also important in flood control and water regulations. And wetlands also could improve the water quality by filtering out the pollutants. And wetland also provide valuable resources for local communities and giving them the economic benefits. In terms of wetland distribution, so this Asia is one of the most important region because this area is hosting 42% of global mangroves. And it is also home to 56% of the global tropical peatland. And it houses around 34% of coral reef in the world. And we can also find other type of wetlands in this region, but unfortunately, wetlands in Southeast Asia has been degraded since several decades ago. So considering this dynamic condition of wetlands, it will be needed for us to monitor wetlands ecosystem to conserve the remaining wetlands area by doing wetland inventory to know the wetland characteristic and also peatland mapping by involving geospatial technology. As I mentioned in the beginning that when it comes to wetland related activities here in WR Indonesia, it will be more focusing on peatland related activities. Actually, we also have kind of mangrove activities, but to relate more with the topics, I think for the next slide, we will be focusing on peatlands. So what is peatlands? This ecosystem is the result of incomplete decomposition of organic materials, and it accumulates and become compacted and forming peat soil, one of the main component of peatlands, along with the water and also vegetations. The formation of peatland occur in waterlogged conditions. That's why this ecosystem also part of wetland. So yeah, again, Southeast Asia is one of the biggest hotspot for tropical peatlands, and Indonesia and Malaysia are among the countries with the largest peatland in this region. Indonesia alone hold around 13.4 million hectares, if I'm not mistaken, and Malaysia around 2.6 million hectares. And we can also find peatlands in other countries in Southeast Asia with a smaller area. Doing peatland inventory and also peatland mapping will be difficult if we only use if we only use ground-based measurement, because peatland area is really huge, really vast area. But the most important thing is that peatlands area are mostly inaccessible, so it will be difficult for us to reach them if we only use ground-based measurement. And this method also labor intensive because it will need extensive amount of pit drilling data, and also it will be costly. So the challenges can be addressed by using the remote sensing and geospatial technologies beside helping us to access the inaccessible areas. We can also map the peatlands with a broader area. And the field observation can also be reduced up to 75% and make it more efficient and cost effective. In 2016, WRI managed to conduct competitions, $1 million competitions, to find the best methodology to find the most accurate method to map the peatlands, both for peatland distribution and also peat thickness. The winner of these competitions, combining the ground-based measurement and also remote sensing method by using LiDAR. Why LiDAR? One thing that we should remember that peatland area is relatively flat. So when we need to map the peatlands, we will also need kind of high resolution, high spatial resolution satellite data. And LiDAR is one of the data that can be used for mapping the peatlands. Beside peatland map, we can also obtain other peatland characteristic using LiDAR, as we conducted in 5 peat hydrological units, the management units that used by the government of Indonesia in peatland management, with the total area around 700,000 hectares in Sumatra and also in Kalimantan. Using LiDAR, we can produce like contour map, a drainage map, and also water flow and land cover maps. This data can also be used for other assessments. For instance, we use the data from LiDAR for assessing the peat rewetting impact. Rewetting is one of the peatland restoration activities that aims to elevate the groundwater level of the peatland by implementing canal blocking and also canal backfilling. And to assess the impact, we can use hydrology modeling, and also we can also assess for the wetting planning, as we conducted in 7 peat hydrological units in 5 provinces across Indonesia. And as we may be aware that peatlands in Southeast Asia, I mean, the intact peatlands, the undisturbed peatlands, is only around 7% of the total area of peatlands. This is because most of them have been degraded due to the human activities like agricultural expansions and also like illegal logging and other human activities. So monitoring peatland is important to understanding the current conditions, the characteristic, and also the vulnerability of to the degradations of the peatlands. And using real-time peatland monitoring will be easier for us to monitor the peatland. But before we dig more into the real-time monitoring, probably it will be better for us to know how is the peatland degradation happen. So as I mentioned before, that peatland in their natural condition is waterlogged, and the peatland degradation happen when there is a canal construction, because it will lower the groundwater level and also will cause the soil moisture lower as well. And this activity also will lead to the peat subsidence, or the downward movement of the peat surface, and also emission of the carbon dioxide into the atmosphere. From this slide, we can understand that there are several parameters that should be monitored for peatland monitoring, like groundwater level and also soil moisture, peat subsidence, and also carbon dioxide emissions. For peat subsidence, how do we know if there is peat subsidence occurrence in the field? Actually, there is a easiest way to know if there is peat subsidence if we see if there is an exposed root in the field. And we can also measure the peat subsidence by using the most common method, the easiest method, using the PVC pipe by inserting the pipe into the soil until reach the mineral soil below the peat layer. And then after that, we can monitor this in a certain unit of time, like per year or per 5 years. But using this method will be difficult because we have to go to the field to obtain the data. So we can use the time-lapse camera method as we implemented by WR Indonesia, collaborating with UK Center for Ecology and Hydrology, also with BRIN, and also with University of Palangkaraya. Using this method, we can monitor the peat subsidence and also other parameters like peat groundwater level and also peat soil moisture. And the most important thing is that we can download the data automatically using the internet. So no need for us to go to the field only for obtaining the data. And for the groundwater level, we can use telemetry method, and there is like platform that provide this kind of data. We call it as Sipalaga. In bahasa Indonesia, we call it as sistem pemantauan air lahan gambut, or in English, literally means pit groundwater level monitoring system. And this platform can be accessed freely by everyone. For observing soil moisture, we can use CEPAL. CEPAL is a platform developed by FAO. Using this data, we can monitor pit soil moisture using the satellite data. And then we can also use this data for monitoring the pit groundwater level by comparing the satellite data with our groundwater level and also soil moisture data observed from the field. Talking about peatland and mangrove monitoring, we can access, I think it is quite advanced platform called PRIMS. Using this platform, we said we can monitor the parameters that I mentioned before. We can also monitor other parameters like identifying the peatland clearing and draining indications, and also observing the hotspot distributions as indicator of pit fires in peatlands, and also other parameters. WR Indonesia was part of the organization that developed this platform back then in 2018 until 2021. Technology is important in sustainable peatland management, but engaging communities is also needed for wetland sustainable management efforts, including in wetland mapping and wetland inventory. But the question is that why should we involve them in our sustainable wetland or peatland management efforts? Probably this triangle can answer or describe the questions. This triangle is about the three main components of peatlands that includes peat soil, water, and also plants. If one of the components is disturbed or degraded, other components will also be influenced. And who or what is the main driver of these three components degradations? And yeah, the question is pretty clear. It is the human, the people, the communities. So if we want to implementing sustainable peatland management, we should involve them because they are the main actor of peatland degradations. We also have to include social, economic, and cultural dimension in peatland conservation and restoration efforts to make it more effective. And by engaging the local communities, we will also ensure that their perspective in peatland management will be included, and it will help us to avoid the conflict with them. And it will also ensure the sustainability by engaging the local communities. Raising awareness activities is the first thing that we can do in terms of engaging the people. It sounds so basic, but it still needed. So these activities will become, will make the people will become more concerned and motivated to protect the peatlands. And also the people will have the better understanding and about the peatlands, and also the need for their conservations. And through this activity also will provide accurate information about the importance of peatlands and preventing harmful practices driven by their ignorance. This kind of activity actually still needed, especially for the people in Lau PDR in Thailand, in Vietnam, in the Philippines, and also Cambodia in terms of sustainable peatland management. This is this information is what we got when we conducted raising awareness activities in those countries through the Pit Ranger program. Basically, this program we selected the local people to become a pit ranger. We enrich them with the knowledge on sustainable peatland management, and then they will deliver the message to the other people through the village events. Around 1,500 people were connected in this activity, and in more than 30 village events, if I'm not mistaken. And the interesting fact is that, as I mentioned before, in Indonesia and in Malaysia, probably they have quite advanced knowledge on sustainable peatland management. When we visited their villages, and we told them that we want to conduct raising awareness activities, they say that they told us that oh, it's a boring activities because previously they already got this kind of activities. So we need to involve other activities. Like in Malaysia, we involve traditional games, and also in Indonesia, we use composting training to attract people to come. But in other countries, beside those two countries, they were really excited, excited to get the knowledge on sustainable peatland management. Regarding the peatland mapping and inventory, it is also important to involve communities because, again, they know better about their areas, about their landscape. So it will improve data accuracy and also data completeness. And it will also enhance community ownership and stewardship. And it will integrate the traditional knowledge of the people. And it will build capacity for long-term monitoring. It will be more sustainable. So we can conclude that the integration of advanced technology and community involvement is crucial for wetland or peatland conservation and restorations, as technology enables precise monitoring and data collections, while local communities contribute traditional knowledge, stewardship, and interest in preserving this vital ecosystem. That's all from me. Hopefully we can discuss further in the Q&A sessions. Over to the moderator. Thank you.
Okay, thank you, Mr. Dede, for that enlightening presentation related to technology utilization and community involvement for wetland management. And up next is Dr. Suyadi from the National Research and Innovation Agency of Indonesia, or BRIN, who will present about mangrove restoration and conservation as nature-based climate solution and community livelihood. Please, Dr. Suyadi, you will have 20 minutes to present.
Yeah, just a second. Yes, can you hear me?
Yes, we can hear you clearly, Mr. Suyadi.
Just a second. Set up my virtual background first, please. Thank you very much, Miss Indria. Today, I'm going to talk about the mangrove restoration and conservation as the nature-based climate solution and community livelihood. In here, I specifically focusing on mangrove, different from the previous speakers talking about the wetland in the in the general fashion. Next, please. Yes. Before I talk about the mangrove forest, I'm going to remind all of us, especially among us who spend their time, their day in the comfort room with the full of air conditioner. And then if we go to the coastal area, especially in the mangrove forest, or if we stay in this area, we feel that climate change or global warming is real. And then we can see here in our data that air temperature and also sea surface temperature increase dramatically, especially since 1970s. Next, please. That is just a reminder, but I think that is an important reminder for all of us. And now we talking about the wetlands. We know that Indonesia is the second largest after Brazil about the mangrove, about the wetland habitats. And then 10% of the wetland in Indonesia is mangrove forests. And we can see that in this map, the below map, we can see that Indonesia is the largest habitat for mangrove forest. Around 23% of the mangrove in the world located in Indonesia. Not only the largest habitat, but also the diversity. The Indonesia is the diversity center for mangrove species, and the mangrove distributed almost in all of islands across Indonesia. Next, please. We are lucky because we as a host of mangrove, the largest and the mega diversity. But remember that we also face tremendous threats of mangrove ecosystem, especially deforestation and degradations, climate change and pollution, especially plastics and oil spills, invasive species, and biodiversity decline. We can see here that mangrove loss in the world, and we can see that Southeast Asia, especially Indonesia, is the highest mangrove loss in the world. For example, here 62% of mangrove in the world have been lost, and most of them due to the human activities. Next, we go to the closer to the Indonesia, please. Next. Now, this is the Indonesian mangrove deforestation and degradation. For example, here the mangrove loss is fluctuated, but we can see that about 40 to 52% of mangrove in Indonesia was lost between 1980 to 2016. And the annual deforestation in Indonesia is about 2 until 6% a year. And then we can see here that the largest mangrove deforestation rate in Indonesia is Kalimantan, followed by Sumatra and Sulawesi. Next, and we can see that this is the alarm from us to conserve and mangrove in Indonesia. What is the driver of mangrove deforestation? Here, we identify some major drivers or the main causes of mangrove deforestation. For example, is mostly mangrove is converted into aquaculture, agriculture, and infrastructure developments. And here we can I categorize the driver of mangrove or the causes of mangrove deforestation is into three layers: agents, intermediate cause, and underlying cause. The agent is individual or institution or companies or anything that they directly cut or disturb the mangrove. And immediate cause is access or resources or skill that they directly drive the agent to conserve, or not to conserve, but to clean or to create the mangrove forest. And the most important is underlying cause. For example, it is policy and regulations and socio-economic conditions. For example, economic crisis and social conflict. For example, in here we can illustrate that the agents, for example, local people around the mangrove forest, they never do that without intermediate cause and underlying cause. Next, please. This is an example of the causes of mangrove deforestation. For example, here, fish ponds and logging, and this is oil spills. We can see that oil spill is very dangerous for our mangrove, even the mature mangrove as well. And then we also find this one, plastic pollution. Based on our research, that all of the sites of mangrove we visit contaminated by plastics. And then here in Maluku, we see that some of mollusks that we find in mangrove ecosystem contaminated by plastic spill. Plastic, I mean the not microplastic but mesoplastic as well. And this is invasive species we find this one in Segaran Cilacap, and then we also find some of occurrence of this species in many locations in Indonesia. Next, please. Okay, what is the impact of the threats? Especially that threat is significantly has negative impact on the ecosystem balance, ecosystem services, especially blue carbon, ecological function, and socioeconomic of local economy. So we need strict or strong conservation effort to conserve the remaining mangrove ecosystem and restore the degraded mangrove ecosystem. Indonesia itself, they have the government has a target to restore about 600,000 hectares of the degraded mangrove ecosystem. Next. This is our research and also research in Southeast Asia conducted by Ellison and Lee, so that a lot of investment or effort spent in the mangrove plantings, and then but only about average to 30% of mangrove planting is successful in terms of propagule survival and area of increase. And then next, please. Next, please. Yeah, and then mangrove planting or mangrove restoration. Actually, this is different, but it's not the new one, but it's start from the 1970s. And that time we call this greening programs, or this is some of approach for mangrove restorations. For example, is coastal protection, community-based mangrove restoration, and so on. And then we need the new approach of mangrove restoration, because we know that the new challenge is coming. For example, invasive species or climate change or many things that we need a new one to make mangrove restoration is more effective and efficient. So we need include ecosystem design, biotechnology, and community-based mangrove restorations. All of this is community-based mangrove restoration. Next, please. For example, here, I highlight this here ecosystem design, biotechnology, and community, because we see that the process of mangrove ecosystem development, of dynamics of mangrove is influenced by uplands, especially the uplands, and socioeconomics, climate conditions, and oceanic conditions. This is based on our study, both in tropical mangrove, especially Indonesia, and the temperate mangrove, especially in New Zealand and Australia. So the mangrove ecosystem is influenced by all of these factors. Next, please. I can't go to the very detail because the time is limited. So now this is the community-based mangrove restoration is very important. Involve the local community. Why? Because local community have the highest direct interactions. We can see here in both positive way or negative way in the green and red circle. And then most of the mangrove planting in Indonesia is undertaken by local communities in terms of technique. I mean, they plant the mangrove in the fields. Others is like academics, governments, and local and NGO and professionals also involved in these restorations. Next, please. But I highlight that local community is very, very vital for mangrove restoration and conservation. For example, here they involved in the mangrove patrols, mangrove nursery, mangrove plantings as well. And then this is mangrove silvo and agro silvo fisheries and ecotourisms, and they use mangrove as a product for foods, drink, and so on. And sometimes, not only sometimes, but they also involved in research as well. Next, please. Next. Next, please. Yes, in terms of biotechnology, in here we invent some of before back please. Back please. Can you back please? Yeah, we send some of products we call actually this is biostimulant or microbial-based fertilizer for specifically for mangrove. Here we call biokusmart. This inventions is to trigger or to improve the mangrove growth. And then this one is bioremediation. We call bioremang. Bioremang is like to remediate the oil spill. So this to reduce the oil spills in the mangrove area. Next. And the next slide, this is the example of the application of biokusmart and bioremang in Poka Ambon. For example, here, all of mangrove in this area is die because of oil spills, and then we apply the bioremang and biosmart, and then now mangrove is grow. Next, and the next is also case in Sekarang Cilacap. This is in the similar things as oil spill as well. We do mangrove restoration or apply with the biokusmart and bioremang as well. Next. Talking about the climate change, I'm specifically here focusing on carbons stocks. We can see here in the top corner, we see that mangrove ecosystem is among the carbon-rich ecosystems. This is the carbon stock is much higher than other ecosystems, especially below ground carbon stock. How about if we go to deep in the mangrove ecosystems itself? Here, I compare between mangrove trees with other stratification, for example, Nipa mix is Nipa, mangrove trees, and Deris. And Deris is invasive species. We can see here that mangrove trees is much higher than other land cover stratification in the mangrove ecosystem. This means that mangrove ecosystem, they store huge carbon stock in both above and below ground carbon stock. And then we can see here in the top of graphs that this is the age of carbon or sediment is on the the below ground carbon stock. We can see here the age of carbon in depth of until 24 centimeters is about 30 or 40 years, but below that is much older. So this means that mangrove ecosystem can store a lot of carbons in soil, and then for the long times. And then the below graph or below figure, we can see that most of mangrove, based on our research, is most of carbons, especially below carbon stock in the soil carbon stock, is coming from terrestrial, from the uplands. You can see here that our stable analysis, isotope analysis, that most of carbon stock in the yes, 5 minutes again. Okay, in the below ground carbon stock is very identical with the terrestrial carbon or sediments. Next, please. And this is the potential of carbon to as a natural-based climate solution. For example, here we know that annual emission because of the mangrove erosion is very high. So if we can avoid this mangrove loss, this will reduce enormous of carbon emission, especially from land use and sector, about up to the 32%. And if we restoring the potential mangrove habitats, we can also increase the habitat. So in Indonesia, also compared to other countries in Southeast Asia and other countries as well, is highest total carbon stock. So there is the potential for to mitigate the climate change through the natural-based climate solutions. Next, please. And how about the local livelihood? This is based on our studies, not all of area in Indonesia, but in some area in Java and Sumatra, that mangrove contribute to the local economics. For example, his mangrove ecotourisms, they contribute to the about the 20 million to 250 millions a year. And silvofishery, for example, up to 500 million a year per hectare. But this depends on the condition of the silvofisheries. And nipa sticks, for example, here, 1 million up to 6 million a month per person. And food, for example, they use mangrove as a raw material for foods, for string, and for snack or for craft. This about 500 or 1.5 million a month per person. But this, of course, is varies because not all of the business or the local business is well performed. It's depend on the people and also the resources. Next, please. Okay, this is the last slide. What we have to take from this presentation is mangrove is one of the most important blue carbon ecosystem for natural disaster restoration, as we I mentioned before, that they can store mangrove carbon stock in both above and below ground carbon stock. Sorry for the noise. And secondly, effective mangrove restoration method is required to improve the success of mangrove restorations. And next is which mangrove and blue carbon. This is about the business model of blue carbon, which are suitable for it. We suggest that mangrove ecosystem restoration and blue carbon business should be considered three important things. The first one is ecosystem balance, biodiversity, and local socio-economic benefits. And then the local community should be have like for community empowerment and economic benefit for them. Next, please. Yeah, thank you very much. This I just to say that restore mangrove is just not planting the mangrove, but starting from making a plan or design until the monitoring and also maintenance. Thank you very much for listening. And with the reference.
Okay, thank you very much, Dr. Suyadi, for that comprehensive overview of mangrove restoration strategies. And thank you to all three speakers for their insightful presentations on sustainable management for wetland landscapes. Next, to add further depth to our discussion, we now welcome today's discussion, Amy Legiones, from the Global Water Partnership Southeast Asia and the Society for the Conservation of Philippine Wetlands, to share her perspective and reflections on the topics presented. Now we will hear from our discussion. Amy, please. The time is yours.
Thank you. Can you hear me?
Yes, we can hear you clearly.
Okay, thank you. So good afternoon, everyone. It is such an honor and privilege to be with three distinguished speakers before me. And now I will humbly try to contribute to the discussion. So my role is actually to provide insights and perspectives on the three topics that were delivered. That the first one was on policy and preservation, the future of wetlands as carbon sinks, technology and community involvement, and mangrove restoration and conservation as nature-based solution and community livelihoods. At this point, let me just say that I am very happy with how the presentations went, because I think the conclusion at the end is we can still have the wetlands as carbon sinks. I think the outlook is very positive. First of all, when Ms. Kisha delivered her presentation, and emphasized that we should champion wetland-based solutions, then that already set the tone for the whole perspective, actually. And I believe that nature-based solutions, knowledge sharing, and investments in high-quality carbon initiatives that will benefit the community and nature as well are really good strategies to lead us towards conserving wetlands so that they can be good wetlands, good carbon sinks today and in the future. And her suggestion to a recommendation for the call to action, which is to strengthen regional cooperation and collaboration among institutions, I think are on point. And according to the next speaker, Mr. Sulaiman, I was very impressed with the technologies that were presented, and I just hope that all of us can afford such, but it is also very gratifying to know that the communities can be involved, in fact, particularly in wetland mapping and inventory, so that we don't only ensure the conciseness of these activities, but we also bring in the traditional knowledge and increase awareness of the communities, which actually lead to their commitment to actually take action for wetland conservation. The various technologies can indeed be very useful tools, particularly in monitoring parameters for wetlands, peatlands, and mangroves. And I think this can even be incorporated into some citizen science activities that the community can do with the experts. And I was also happy that as part of the community involvement, they were also discussing CIPA, or community communication rather, capacity building, education, participation, and awareness among the community, because it is very important, since he also emphasized the interconnection between water, peat, plants, and are actually interacted by the presence of human beings or the people. And for the paper of Dr. Sayadi on the mangroves, yeah, I think it's also true in the Philippines. The degradation of mangrove had been very remarkable. Like for the 1900 figures, we had about 500,000 hectares of mangrove. And as of the year 2000, we only have half of that left, about 256,185. So although there had been a lot of initiatives already on that, I think we still have to do a lot of catching up. So at this point, let me also just add to the discussion by giving some short, I have a short PowerPoint deck that I prepared. Some of these have been discussed by from Wetland International, but I will just breeze through it very briefly. So these are the wetland types, and the Philippines has most of this except for the snowfields and the glaciers. So we have inland wetlands, coastal and marine wetlands, and human-made wetlands. And let me just focus on the Philippine peatlands. As of now, we have identified about 24 areas with peatlands, but only about 20,000 hectares, which is just 0.006% of the land area of the Philippines. And this is one of the first that was actually studied. This is the Kaimpugan Peat Swamp Forest that, according to Alibo in 2011, stores about 22.9 metric tons of carbon, and the latest Sabah peatland. And these are some of the initiatives that I would just like to share in the Philippine context, just so we know, or we can appreciate that indeed, I think we are moving forward even just an inch into conserving our wetlands. So as mentioned earlier, we were very happy this month because it was announced that we have 2 new Ramsar sites. And these are the Del Carmen Reserve, Mangrove Reserve in Siargao Island, and the Sibugay Wetland Nature Reserve. So now we have a total of 10 with a surface area of 431,890 hectares. We also have a National Wetland Conservation Program, which is actually embedded in the Philippine Biodiversity Strategy and Action Plan. So under this are several strategies and activities that guide the implementation of wetland conservation in the Philippines. And also a Philippine Inland Wetland Conservation Program. And these are some of the wetland policies and guidelines that were issued in the past years. We have a National Action Plan on Wetlands, which was updated in August, but I don't think the updated version is already out. There are also other government interventions, for example, water quality monitoring, vulnerability assessment of watersheds, watershed characterization, and integrated river basin management and development master plan. There are also the national commitments, which is the Philippine Development Plan, and of course the PBSAP, or the Philippine Biodiversity Strategy and Action Plan. These are some of the water and wetlands related policies that were issued. And of course, the international policy frameworks, which include the Ramsar Convention, CBD, the ASEAN agreements, the CMS, and the others. Okay. We also have pending legislations at the Congress, and hopefully in the next, these are both for wetlands in general and for peatlands conservation. We are hoping that in the next Congress, it will be given priority. And recently, as I mentioned earlier, the National Action Plan on Peatlands was updated, and this was in August this year. And at this point, I would just like to introduce very briefly my organization, the Society for the Conservation of Philippine Wetlands. Our mission is, our objectives are to facilitate linkages and networking among wetland advocates, engage in wetland conservation activities, provide technical assistance and a forum on wetland-related issues, and complement wetland activities through research, training, and SIPA. Right now, we are implementing 2 major activities aside from the site-based activities that we are conducting. Okay. The first one is the Living Lakes Biodiversity and Climate Project. This is a 5-year project across 10 countries being coordinated by the Global Nature Fund of Germany, funded by the International Climate Initiatives, where we conduct 17 training courses and 4 learning visits, and implement Frontrunner Initiative, which is the establishment of a farm tourism enterprise centered on a wetland center, and a showcase project, which is the establishment of the green filters or constructed wetlands at the Pangil River Eco Park, which is an innovation because we are using bio-augmentation to accelerate the treatment of sewage in this park. And this is the new project that we are implementing. This is UNEP Jeff funded project, which is the Strategic Action Program for the South China Sea and the Gulf of Thailand. We just started it this month. And the total hectareage that we are targeting to restore or rehabilitate are 4,358 hectares of mangroves, 4,406 hectares of coral reefs, 1,865 hectares of seagrass meadows, and Actually, this is the Malampaya Sound, the wetlands, 52,112 hectares. Okay. And in 2 weeks ago, we conducted the 10th Asian Wetland Symposium, where the theme was wetland-based solutions, and we had 80 oral presentations and 30 poster presentations, with also a session on wetlands and carbon. So we think that with this, we are able to contribute to the Ramsar Strategic Plan, the Sustainable Development Goals, and the Kunming-Montreal Global Biodiversity Plan. And the continuing activities that will be implemented are, of course, the updating and inventory and mapping and assessment of peatlands and other wetlands, research and knowledge management, communication, capacity building, education, participation, and awareness, or SIPA, stakeholder engagement and partnerships, particularly in the Kaimpogan wetlands, where the Biodiversity Management Bureau is already negotiating a carbon offsetting partnership with a private corporation. And we will be increasing restoration efforts, particularly through the SCS sub-project, and of course, monitoring. So with that, I think we can say that we are protecting wetlands for our common future, which is the next theme for World Wetlands Day on February 2, 2025. And we look forward to value, protect, and inspire wetland conservation so that they will still be carbon sinks for the future. So on that note, thank you.
Okay, thank you, Amy, for your enlightened perspective. Now we have reached the Q&A and discussion part of our webinar. For the participants, please share your questions via chat or raise your hand, and we will discuss it with our speakers and discussants. Okay, please, for the participants, if you have any questions to ask to our speakers and discussants. Okay, we already have 3 questions. Okay, we will let the participants who raise their hand first. Please, Mr. Fajar Apriana, to share your questions.
Okay, thank you. Miss India. Good afternoon.
Sorry, Mr. Fajar,
Yes,
I think your voice is unclear.
check.
It's a
Check.
little
Okay, clear my voice?
Yeah,
Clear my voice?
can hear you
Okay.
clearly.
Okay, thank you, Miss India, and all speaker now. Okay, now, you want to go, we have agreement of the agreement about new financial agreement and big benefit and influence as wetland and reduce carbon. Okay.
Sorry,
Like you
Mr.
said. Yes.
It's still unclear.
Yes.
Maybe you
My
can
voice?
write.
Okay, my question is how much a benefit to the reduce carbon of both is wetland and mangrove? That's my question. Okay, good news. Hear my voice? Check, check, check. Yes, can hear my voice?
Okay. Yeah, we get your questions.
Okay,
So your
okay.
question is how much of the benefit to reduce carbon from wetland and mangrove?
Yes, okay, okay.
Yes.
Thank you, Miss. Attention now. Okay, thank you.
Okay, thank you. Maybe this question can be asked by Dr. Suyadi.
Can you repeat the question, please, from Ms. Pasai? Because
Oh yeah,
voice-
the question is how much of the benefit to reduce carbon from wetland and mangrove?
Okay, thank you, Ms. Indria, and thank you, Pak Fajar, for the questions. Actually, we make a calculation. If we, for example, in my last presentation, that if we avoid the mangrove deforestations, we can reduce a lot of. I forget the number, but this is a lot of carbon emissions for land use sector. And if we restore the degraded mangrove ecosystem, we also add a lot of carbon stock, or we can like a carbon offset of from the land use and then carbon sinks as well. I forget the name, but we have to we did the calculation, not only the how much the carbon stock, but also how much the carbon dioxide in equivalence, and also converted into economic value. But I'm forget the detail of the, but this one is very significant for to carbon offset of in Indonesia, because we know that Indonesia is the largest mangrove habitats, and also have a large area as a potential habitats. And now, not only Indonesia, but also many countries in the world, for example, Singapore, China, and so on, they spend a lot of effort and investment for mangrove restoration and restoration in terms of carbon offset as well, especially in the business model of carbon trades. I think that's my question. I hope this answers your question. Thank you, Mr. Indira, Miss Indira.
Okay, thank you, Dr. Suyadi, for the comprehensive answer. Next, we have another question from Miss Louise, who raised her hand. Miss Louise, are you still connected with us? Okay, maybe we can skip to the next question. Maybe for the next is Ish Karima, who raised her hand.
Okay. Are you listening me clearly?
Yes, we can hear you clearly.
Okay, I'm currently conducting research on climate and mangroves in Semarang. My question is, what are the solutions for land subsidence and land subsidence and the erosion of mangrove areas and their ecosystem, which are also caused by pollution from industrial areas? That's my question. Is that clear?
Yes, it's clear. Maybe this question can be addressed by Dr. Suyadi. It's about mangrove, and maybe Kisha can also answer this question. Yes, please, Kisha or Dr. Suyadi to answer the questions.
Yeah, Miss Karima, your question is very, very good, because my team also do similar thing research in Demak, Semarang, Karimun Jawa, and so on. And then we also find similar things, that the problems of mangrove ecosystem in not only in Semarang actually, but in northern part of Java, or we call Pantura. This is because of subsidence. There are the subsidence and land subsidence and erosions. Yes, firstly, land subsidence based on our research and also from the literature. This is due to some factor. For example, the water, I mean the soil water exploitations as well, and also due to the what we call in the ecological, we can subsidence. So based on the literature and also our research, that we can see that Java in the north is going down, and then, for example, in part of Karimun Java is going up. So like a subsidence. So I afraid to have to answer you about the what is the best solution of this. My question is, we still need more research to get some solution to do it. But some of our effort to solve the problem is, for example, we invent some like what we call wave bridge. So we develop something like a seawall to accumulate sedimentations. So to avoid, not to avoid, but actually to minimize the impact of the wave, for example, because we know that in North or in Pantura, the problem is not only land subsidence, but also sea level rise as well. Definitely, we still working on that, all of us, how to get the solution of this very serious problem. Sorry if I'm not answer your question, because actually this is very challenging until now. Thank you.
Thank you, Dr. Suyadi, for that answer. Maybe Kisha, are you still joining us?
Maybe we have to reduce the soil water exploitations and limited constructions in the coastal area, but I don't know, because ecology and economic is always do like that, but we need solid solutions, not only based on the regulation, but also the technology and so on. Sorry.
Okay, thank you, Dr. Suyadi. I think, unfortunately, Kisha has left our webinar due to another occasion. But if you have a question for her, you can write your questions and your email in the chat box, and we will connect you to her to discussing your questions. Next, for the next question, I will let Raisa Rifat to ask your question. Maybe you can turn on your microphone.
Okay. Can you hear me now?
Yes, we can hear you.
Okay, great. Thank you for the chance to for the opportunity to ask this question. I would like to hear more about remote sensing technology for peatland mapping, especially for 3D mapping of peatland domes. I think it was Mr. Dede Sulaiman who explained this, and I think I'm also interested in hearing more about hydrological monitoring in the terms both in the context of IoT, and also perhaps, if I'm not mistaken, he also explained about remote sensing to use for hydrological monitoring. So yeah, I'm asking about like 3D mapping using LiDAR and hydrological monitoring. Thank you.
Thank you, Raisa, for education. Maybe Mr. Dede.
Yeah, thank you, Raisa, for your interesting questions. And actually, it will be a long explanation about LiDAR, but basically, LiDAR is a remote sensing technology that uses the laser pulses to measure the distance and create the 3D models of the Earth's surface, including in peatlands ecosystem. So it will produce kind of a point cloud of individual point that represent everything on the surface, including the elevations. So from this, from LiDAR, we can map the elevation of peatlands, and we can also know where is the peat dome using the elevation data. So yeah, this is the the basic explanation about the LiDAR to produce the like elevation data and to know the peat dome. And regarding the hydrological modeling, peatland hydrological processes is kind of the how to say complex processes. So when we want to predict the hydrological processes in peatland area, it will be we will need a lot of data like peat peat distribution map, and then peat soil characteristics, and then digital elevation model, and also land cover maps. And some of the data can be provided by using the LiDAR data, because LiDAR data, as I mentioned before, can produce like land cover map and also other data that can be used for hydrological modeling. Yeah, hope it answer your questions, Raisa.
Yeah. Sorry. Can I like ask something as a follow-up? Okay. No.
Yes, you can, of course.
Okay. If can I read maybe an article about this somewhere, because I did my research on wetlands as well, so would like to learn more, if that's okay.
Yeah. Sure. Probably I can share the link to you through the chat box.
Okay, thank you, Raisa and Mr. Dede. I think we missed one question from the previous question. It's from Artia Sari. It's a question for Mr. Dede. The question is, it's interesting to use technology while improving community awareness for sustainable peatland management. However, implementing technology can sometimes be challenging for communities to adopt. How can this challenge be addressed? Maybe Mr. Dede can answer the questions.
Thank you, Indria. And the question is from Artia Sari.
Yeah, Artia Sari.
Yeah. If we talk about technology and also local community, sometimes it doesn't match, because as we know, sometimes communities really hard. I mean, there will be difficulties for them to use technology, you know. So the first thing that we have to do to ensure that the people can use the technology in peatland monitoring is that first we have to identify the level of knowledge of the people. If they still need the awareness activities, we have to give them the raising awareness activities first. And then we also have to identify the need. I mean, we have to hear from them what they need in terms of the peatland monitoring. I mean, if there is already peatland monitoring activities, we can connect this with our invention, like mobile-based reporting, for example, as we conducted in several areas in Indonesia. So for monitoring the peatland, for example, for monitoring the peat groundwater level of the peatlands, probably we can use the simple method that the people can monitor it easily, but then they can report the result through the mobile-based platform. So they can report this through this platform, because we know I think a lot of the people currently have the mobile with the internet, So I think if you talk about the people and also the local communities, mobile-based technology will be more easier for them.
Okay, thank you, Mr. Dede, for the answer. And we still have time for another questions. Maybe for you who have questions, you can raise your hand or write it in a chat box. Please, anyone who have questions, you can write it on a chat box or raise your hand. There's a question from Nashwa Swastika. The question is for Dr. Suyadi. So Nashwa asks, it is written that one of the underlying causes of mangrove deforestation is about power relation in politics aspect. My question is, what strategies can be used to increase political will for mangrove conservation in regions where deforestation benefits powerful actors like big corporations? Maybe Dr. Suyadi can answer Nazwa's questions. Dr. Suyadi, are you still joining us? Hello, Dr. Suyadi. Oh, I think Dr. Suyadi has a problem due to his connection. Yeah, he is joining us right now. Dr.
Sorry.
Suyadi? Yeah.
Yes. What is the
Okay.
question?
Yeah, there's a question from Naswa Swastika. The question is,
Recording in progress.
it's written that one of the underlying causes of mangrove deforestation is about power relation in politics aspect. The question is, what strategies can be used to increase political will for mangrove conservation in regions where deforestation benefits powerful actors like big corporations?
Oh, thank you very much, Miss Nasya. This is a very nice question as well. What these strategies can be used to increase political will for mangrove conservation? Oh, this is about the politics. So actually, this is not my area, but I'm going to answer based on my perspective. The first one, we have to provide because we know that the good policy is a science-based policy, because this is they make a policy or develop the policy based on the data. If the stakeholders make the decisions or the policy based on the science, but sometimes the stakeholders there is like, I think not dilemma, but there is two things. First one is for based on the data or science, and based on the what we call other sides. I have to be careful to say this one because I'm not the political one, but based on the perspective of a scientist, the important things we have to do is we have to inform stakeholders, especially governments, not only government, also for legislative as well, about what happened in our environments based on data. Because I know that some stakeholders, they maybe don't understand, or maybe they want to do this one, but we have to inform them, and not only inform but to translate. This is the big challenge between the scientific findings and the policy. A lot of policymakers, they don't want something very scientific informations. They have difficulty. Sometimes they have difficulty to understand the scientific thing. So scientists or academics, they have to translate the scientific findings into policy, or we call a policy brief or something like that, with the simple ones. This is, for example, for us. And the second one, we have the public awareness, because we know that if the people, or for example, netizen, for example, if they aware about our environment, especially mangrove forests, so our stakeholders will pay attention about this, because the stakeholder, the politician, they usually pay attention about their what we call the people. So if there is a massive awareness about the mangrove conservation and restorations, so the stakeholders, the politician, will concern about this one as well. I think that's my question, Mbak Nasya. Thank you. My answer. I hope this answer your questions, please. Thank you.
Okay, thank you, Dr. Suyadi, for the answer. I think we still have several minutes for the Q&A sessions. To everyone who still have a question, you can write your question. Okay, there's another question to Dr. Suyadi from Mr. Pandu Subianto. I will read the question. In the context of mangrove conservation, which approach tends to be more effective? Restoring damaged mangroves or planting new ones? And what factors should be considered when choosing between these two strategies? Please, Dr. Suyadi.
Sorry. Yeah, thank you, Ms. Indria and Mas Pandu. Thank you for the questions. Before I answer your questions, I have to mention here that planting the new one. What do you mean planting new one? I assume that the planting new one you write here is you plant in the, for example, in the mudflats, not the degraded mangrove or damaged mangrove. There is one important thing that we have to take account in the mangrove restoration and or rehabilitation. So based on the international conference, we know that, for example, many of mangrove plantings in Indonesia is conducted in mudflat area, or sometimes in the seagrass area. So here I'm going to underline that mudflats, seagrass is also ecosystem. So based on the ecological side, when the international community as well. Also, we not allowed to plant mangrove in other ecosystem. For example, in seagrass or in the mudflats. Based on in the international communities conference, in the international conference, I forget. I have the books that they declare that mudflat is also ecosystem. A lot of biodiversity use this as a habitats and also feeding ground as well. So actually, it is not good if we plant mangrove in the mudflats. So if the mudflat is occupied by mangrove naturally, this is okay, this is natural. But if we plant mangrove in a mudflat, this is to be considered that mudflat is also ecosystem. So we not I not suggest to plant mangrove in the other ecosystem. This is the points. And going to the your questions, I prefer to restore degraded mangrove. If you plant mangrove in the market, that is not restore. Restore is to put it back. This is mangrove, but this is degraded. The ecosystem is degraded, and then you going to restore to make it mangrove again, to back like a mangrove before this ecosystem is degraded. And what factor we should consider when choosing between these strategies? Yes, I mentioned I prefer to restoring the degraded mangrove. But if we are going to restore damaged or degraded mangrove, we have to know the local condition, the environmental condition, because if we're going to restore degraded mangrove because of converted into fish pond or shrimp pond is different from other side. So we have a very specific approach. Maybe you can email me or something like that, so we can discuss, because this is very techniques and this can be very detailed. So I afraid that we don't have time if I discuss here. Actually, we develop not site specific, but specific restoration techniques. For example, for degraded mangrove due to ponds, or for invasive species, for example, oil spills, contaminants, or so on. So we developed a specific approach for kind of degraded mangrove. Thank you, Ms. Indria.
Okay, thank you, Dr. Suyadi, for the answer, and Pandu for the questions. We still have several minutes for the Q&A sessions. Is there anyone who still have questions? You can write it in the chat box, or you can just raise your hand. Okay, I think there is no question anymore. So we can jump to next session. And before finalizing this webinar, I want to remind you who have not filled out the attendance form to fill out the form by scanning the QR code or clicking the link on the chat room. Also, please find the shareable materials of our two topics presented today. Okay, now we have reached the final session of this webinar. I want to thank all our speakers, Kisha Muanya, Mr. Dede Solaiman, Dr. Suyadi, and our discussant, Amy Lekiones, for sharing your knowledge and insight today, and to all participants for your active engagement. Today's session has emphasized the importance of collaborative efforts in sustainable wetland management for a resilient Southeast Asia. Our speakers have shown that policy integration, community involvement, and technological advancements can enhance wetland conservation then protect them as the most efficient terrestrial carbon sink on our Earth. As presented by Kisha previously, Southeast Asia is in the forefront on the context of wetland conservation and management. Southeast Asia has showcased a strong commitment in protecting wetlands' critical role as one of the prominent carbon sink reservoirs. One of the efforts is shown by the regional and international cooperation for peatlands and wetlands management, such as transboundary cooperation in the Mekong River Basin, initiative in Sulu, Sulawesi, and Coral Triangle initiatives. Another question that arises in the discussion is, can wetlands still be a carbon sink? We agree that the answer is yes, but unfortunately, wetlands' ideal function is continuously under threat due to human activities and the adverse effect of the climate change. Thus, we can conclude that implementing science-based policy, strengthening collaboration within stakeholders, conducting knowledge transfer, as well as proper zoning are therefore imperative in protecting our future of wetlands. We also have another insightful discussion from Mr. Dede Sulaiman, who highlights the key role of Internet of Things or IoT in monitoring peatland ecosystem. The use of IoT technologies in peatland management is essential for obtaining real-time data on environmental conditions, characteristic and ongoing process of peatland degradation. Through IoT-enabled sensor and monitoring system, we can track critical factors such as moisture levels, temperature, vegetation health, and carbon emissions, which are key indicators of peatland stability. And this data helps to understand the current state of peatland, predict potential risks, and formulate effective strategies for restoration or sustainable management. But while technology plays a vital role in understanding and managing peatlands, the involvement of local communities is equally important. The answer to why we need community involvement in sustainable peatland management lies in the fact that local people are often most directly affected by the balance of peatland ecosystem is disturbed. Peatlands are not only ecologically important, they are also closely linked to livelihoods of the people who live in around them. These communities depend on peatlands for resources such as water, fuel, and agricultural land, as well as for cultural and spiritual practices linked to the land. When peatlands are degraded, it's the local communities who suffer the most, including loss of livelihoods, health risks, and displacement. From Mr. Suyadi, point of view, as the largest mangrove area in the world, and Indonesia has experienced huge mangrove deforestation over the years. And the main drivers of mangrove deforestation, aquaculture, agriculture, and infrastructure development that undermines its quality. Dr. Suyadi has also shown in his presentation about mangrove ecosystem traits, impact of the trait significantly impact the balance of ecosystem. Therefore, we need to strictly conserve the remaining mangrove and restore the degraded mangrove ecosystem. Mangrove restoration is not a new thing. It was started in the 1970s with various approaches. But as new challenge emerged, that's why the program changed, and we now need a community-based mangrove restoration. Why is community-based restoration important? Because the community itself has direct interaction with the mangrove ecosystem. Besides that, carbon has potential as nature-based solution in order to avoid the mangrove loss and to reduce the threat of ecosystem the challenge. Mangrove ecosystem restoration and blue carbon business should consider ecosystem balance, biodiversity, and local socio-economic benefits. Lastly, Dr. Suyadi closed his presentation with an evocative message that restoring the mangrove ecosystem is not just about planting the mangrove, but starting from making plans, doing constant monitoring, and conducting maintenance. Emil lectiones combine all ideas from all our speakers, how government, technology, and communities. We can also learn about wetland management practices from the Philippines, which has a national wetland conservation program embedded in its biodiversity strategy and national action plans. And as we move forward, let's encourage collaborative approach, empower local communities, and increase innovation to protect this critical ecosystem for a resilient and sustainable Southeast Asia. And once again, thank you for joining us today. And I will hand it over to our MC for the final closing. Thank you, everyone.
Yeah, thank you, Miss Indria, for expertly moderating today's discussion. And once again, special thanks to our speakers, Semuanya from Wetland International, Mr. Dede Sulaiman from World Resources Institute Indonesia, and Mr. Suryadi from National Research and Innovation Agency, or BRIN, for the insightful presentations. And I would like also to thank our discussants, Mrs. Ami Lesiones from Global Water Partnership Southeast Asia, for the valuable insight. And to all participants, thank you for actively engaging in this discussion. We hope today's sessions has provided you with valuable insight into sustainable wetlands management. And I would like to remind to fill out the evaluation form through the link or QR code displayed on your screen or in the chat box to receive a certificate for this event. And that's it from me. Once again, thank you for joining us today and have a great day.